Good morning. Today we are doing lesson 6-5. You will need your math book and turn to page 280 and 281. If for some reason you did not bring your math book home with you, you can always go to the Perry Township Resource Portal, and then on the right-hand side, you go to the McGraw-Hill. Click that. Yours might look a little different, but it will get you here to everyday math. And today's lesson should line up and say lesson 6-5. Yours won't look exactly like this. This is the teacher dashboard, but you can find the resources and your book on this page. All right, so today we're looking at a balancing act with pan balances. If you do not remember the lesson before spring break, I suggest going to watch those videos before starting today's lesson. For today's math message, it says, these two pan balances are in perfect balance. That means that one cylinder equals two circles, spheres, okay? And then one cube equals one circle. Those are equal to one another. So if I know that one cube is one sphere and one cylinder is two spheres, then one cylinder would also be two cubes. So we're going to use those relationships in the pan balances above to determine which of the pan balances below are balanced. Circle the ones that are in balance. We're just going to find the ones that are balanced and then circle the ones that are. So if I look at this one, to know if they're balanced, then those are going to be equal on both sides. So here, if we were talking in terms of spheres, we would know that this one should equal 4 spheres because there are 2 cylinders, and then another sphere because we have this one right here. So that would be 5. And on the right side, this one would equal 2 spheres, and then a cube equals 1. So those would not be balanced. We would need 2 more spheres to make this balanced. So I could draw on 2 more spheres, but also a cylinder equals 2 spheres, so I could draw on a cylinder, and then that would be balanced. If we look at the second one, in terms of spheres, the right side is 4 spheres. We know that 1 cube is a sphere. We have 2 spheres, and a cylinder is 2. So that would be 4 spheres on the left and 4 spheres on the right. So those would be equal to one another. We're going to circle that one. Let's look at the next one. Here we have 4 cubes on the right, and we know 1 cube equals 1 sphere. So these would be equal. We'd have 2 and 2. And then 1 cylinder equals 2 cubes. So that would be 2 more cubes here. So that this pan balance would be equal. And then the last one, we have a cylinder on the right, and we know a cylinder equals, right here, a cylinder equals 2 spheres. So this would be, the left side would be heavier because we have an additional cube. So to balance that on the right, we could draw another cube, or we could draw a sphere because the cube and the sphere are equal to one another. So the one on the right is not balanced. Right, for the bottom portion, now we have expressions on the bottom. So it says circle the pan balance that is balanced with equivalent expressions. So remember the word equivalent means equal. So we want to find the pan balances that are equal on both sides. So if we look at the first one, here we have 4 times 7, which we know is 28, plus 2 equals 30. So the left side of my pan balance is 30. And remembering to follow the order of operations. I did multiplication before I added. And then on the right side, 6 times 5 is also 30. So that pan balance would be equal. Go ahead and circle that one. Now, the next one on the right, we have 3 plus 8 times 2. We're trying to see if it's equal to the 11 plus 6. So the expression on the right, we're going to do the parentheses first. So 8 times 2 is 16. And then we will add 3 to that, and we will get 19. So the expression on the right equals 19, and the expression on the right, or the left equals 19, and the expression on the right equals 17. 11 plus 6 is 17. So is that pan balance equal? No. We would have to add 2 to that expression to make it equal. So we would have to have 11, because 2 more would make it 19. So if it was 11 plus 6 plus 2, then that would be equal. All right, the one here, we have 9 times 5 and 5 times 12 minus 7. So let's start with 9 times 5. Okay, 9 times 5 is 45. And then on the right, we need to do our parentheses first. So what is 12 minus 7? It's going to equal 5. So then we have 5 times 5, which equals 20. So those would not be balanced. We need 20 more to make that balanced. So I'm just going to put plus 20 here. That would make that pan balance balanced. Okay, the next one, we have to do our parentheses first. 3 times 4 is 12. 14 minus 12 would equal 2. So the left side equals 2. The right side, we're going to do our parentheses first as well. And we have 11. 14 minus 3 is 11 times 4. So this side would equal 44. So to make this balanced, we would either have to add 42 to the left side or subtract 42 to the right side to make that balanced. Okay, on page 281, you are going to balance each pan balance. Record equivalent expressions in each pair of pans. Use expressions from the list below. You will not use all of the expressions. So on this page, what you're going to do is find equivalent, which means equal, expressions and put one on the left side of the pan and one on the right side. So for example, if I look at the very first expression, okay, this is 7 times 5 equals 35, plus 10 would equal 45. I suggest solving all of these expressions first to see which ones would be equal. So for this expression, it would be equal to 22.5 times 2. Because I know 22 times 2 would be 44, so 22.5 would be 45. So I'm going to write both of these expressions on my pan balance. Here and here, one on the left and one on the right. So 7 times 5 plus 10 is equal to 22.5. So next, I want you to do the next two pan balances. When you're solving these equations on the left, remember to follow the order of operations. So first you're doing parentheses, then exponents, then multiplication and division from left to right, and addition and subtraction. Okay, remembering that exponents, like right here, where you have 2 to the 4th power, that is like 2 times 2 times 2 times 2. The biggest mistake I see is people adding those and getting 8 as the answer. 8 is not the answer. You need to multiply all of those 2's together. So go ahead and pause your video and complete the next 2 expressions, or the next 2 pan balances. All right, hopefully you have paused your video and found the expressions that are equivalent or equal to one another and put them on your pan balances. I'm going to show you the correct answers now. All right, so you could have these in either pan balance or flip-flop the left and right, but these are the expressions that are equivalent. So if you did not get those answers, check your work and find your mistakes. We're going to move on to number 4. All right, for number 4, it says find the value of the missing number that will balance each set of pans below. The same number is missing from both sides of the pan balance. So if we look at letter A, we're trying to find a number that could fit in both sides of our pan balance, so where the square is. Okay, so what would the square have to equal? It's going to be the same number on both sides. So if I plug 1 in on this side, I'm also going to plug 1 in on this side. So here, 1 plus 3 equals 4. 2 times 1 equals 2. So those are not balanced. Okay, so I'm going to do plug and chug or guess and check. So let's try 2. Here we have 2 plus 3 equals 5, and 2 times 2 equals 4. So that would not be equal. Let's try 3. Oops. So 3 plus 3 equals 6, and 2 times 3 equals 6. So 1 square equals 6. Okay, go ahead and complete B, C, and D. You will pause your video, and when you resume your video, then I will show you the correct answers. So go ahead and pause now. All right, hopefully you tried to solve these on your own. For letter B, the square would equal 10. For letter C, the square would equal 2. And letter D, the square would equal. Okay, once you are done with this, you are going to play the Seesaw Logic game that you should have played before spring break for extra practice on pan balances. Then you are going to do your HomeLink 6-5. For your homework, number 1 says it's just like your math book. These 2 pan balances are in perfect balance. So here it is telling us that 1 hexagon equals 2 halves of a hexagon, or a trapezoid. So then over here it tells us that 3 triangles equals 1 of these halves. So if 3 triangles equals 1 of these halves, or a trapezoid, how many triangles would a full hexagon equal? So if 1 half equals 3, then a full hexagon would equal 6 triangles. So use this information and the information that they give you here to solve the top portion of your homework. And then on the bottom, you are going to be using expressions. Please email me if you have any questions. You can also contact me on Student Square, and you can message me very quickly. Both of them, I will try to get back to you as soon as possible. Have a great day.